Welcome to another math lesson. We're on a new unit with some new topics. Actually, a lot of what we're going to do in this unit, oh boy, you're going to have to bring back from your memory a little bit. From our graphing unit that we did a while ago, we're going to be using the information and the knowledge you have from all of that in this one. So pay close attention. So today, welcome to another math lesson. We are moving on to Unit 12 called Functions. And I don't want you to get scared about that word because a lot of what we're going to be doing, you already know how to do. So we're just kind of going to bring it together and help you look at it in a new way, all along the idea of evaluating and looking at information and figuring out what it means and what can I do with it. So, today we are going to learn about graphs that represent functions, and we're going to figure out which graphs do represent functions and which ones don't. We have a very simple test that is really easy to use. So let's take a look. First of all, what is a function? Well, if you think about any kind of apparatus, I want to say machine, but not even just machines. I mean, a blow dryer, what's its function? Cold air comes in, hot air comes out. That's input, output, right? Washing machines, dirty clothes and water and soap goes in, and hopefully, if it's working right, clean clothes come out, and hopefully all the clothes you put in and none of the socks got lost. So input, output. Input, output. I don't know which way I should do this. I'm not sure which way shows the right way because I'm looking at the screen like you are. But anyway, so you have these machines or these gadgets. I mean, I have a blender. I put fruit and yogurt and different things in, and I push the button and I make lots of noise and then stop it, and out of the blender comes this nice, maybe like milkshakes, you know. Ooh, you put the right things in, it'll be so yummy. But anyway, that's what a function is, all right? You're going to see it called, you're going to hear me say this, and you're going to see this in a lot of places. We call it a function of x, all right? We put something in, an input, x, okay, is the typical one, and you'll see lots of other letters that are going to go in. But right now, we're just going to talk about x and y. So x goes in. Something happens to it, and we're going to talk about equations and putting in an x value, and then we get an output, a y value, or it could be anything, any letters, but for now we're going to talk about f of x, and f of x is actually our output, or y. I mean, you'll see what I mean in a few minutes, but anyway, it's not our output, but y would be our output, and we're going to just plug stuff in, and it's going to chug, 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 and plop it out. That's it. It's really not hard, but so don't panic, okay? Don't panic. So here's how we do a function. All right, functions, and I know these words are big, but you guys can handle these. A function defines a relationship between x and y in such a way that each x value yields only one distinct y value. Okay, so in other words, an x has only one y. So you put in an x value, some value for x, you do something to it, and here's an example of a simple equation. All right, this is what we're going to do to our x, and out comes the y. So if I put in a 1 and I add the 5 to it, I get a 6. It's that simple. It's really not any more complicated than that. So what I want you to do right now is enjoy this little video, pay attention to what they're saying, talking about f of x, what that means, and a few other things. Have fun. All right, so I hope a la Shmoop that Shmoop was able to help you. If you didn't understand everything they said and sang about or talked about or, all those things, hang on. I'm going to get into it in a little more detail. But we're going to talk this lesson only about graphs as functions. This is the visual test. For you visual people, this is the one that you're going to like. Next lesson, we're going to get into another way of checking out functions when they're not on a graph for us, okay? So right now, we're going to talk about graphs. And as you can see, we've got these two cute lines here. Aren't they adorable? Yeah, right. Anyway, these are actually graphs of these equations. And we're going to learn about how to tell if something like this is actually a function. Remember, an x has only one y. That's the key thing here. So in a graph, when we're looking at pictures of graphs, we're going to use this thing called the vertical line test right here. These three words. This is a really important term, the vertical line test. That's what you're going to use for this lesson. You're going to look at these graphs and you're going to use a vertical line. Here's our red line. And notice no matter where I put it on this graph, I'm only going to cross the line once. That's the key. If you only cross it once, then yes, it is a function. If you look over here, notice the squiggly right here. We've placed the red line right there, showing that this x value, let's see, it would be, let's say it's -5. I can't tell because I don't have any grid lines on it. But let's say it's -5. -5 can be, looks like a -2. It looks like it could be a 0, and it looks like it could be a +2. That makes it not a function. Weird, right? Okay, so reviewing, a function defines the relationship between x and y in such a way that each x value only gives us one distinct y value. Okay, now we're going to cut this word down. You're going to hear in a lot of places, instead of the word relationship, you're going to hear the word relation. Okay, so, math, we just don't like throwing in any extras that we don't need to. So you're going to hear a lot and see this in your questions, like on your prove it. It's going to say, in this relation, blah, 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 blah. Here's your question, okay? So don't panic when you see just the word relation. It's just relationship, okay? You can think in your head, add the ship if you need to. All right. Let's take a look at some examples. Here's a couple of line graph examples, straight lines, that are indeed functions. As you can see, no matter where I would put this dotted line, my vertical line test, all right, no matter where I put this on here, I'm only going to get one time where it crosses the line. Same here. Straight lines are real easy to tell. As you can see, oh, but wait, there's these weird ones that come up every once in a while. Got to show you the weird ones. Now let's take a look. This is some new notation that at least we have not covered in this class yet. And, you can see on the left here we have our straight line, and it stops here. Notice this is solid, and then it starts again up here and it goes off to the right, and this one is open. It's got a hole in it. What that means is, on this line right here, the x value is here, okay? That's what the solid dot means. This x value is this x value, which is 0, yeah. All right, at x equals 0, y equals probably -1 would be my guess, right? Up here, where x equals 0, there is no y. The open means this is not included. So, if we were to use a vertical line test, and this would be the only place would be a question, is right on the y-axis, this is a function because this shows us, no, this is not a value for it. Okay, so it comes up to this point, and then it jumps up here and it goes across over there. So this is a function. If you ever come across a weirdo like that one, let's take a look at some curvy ones. Now, this one, I did a little animation, so watch carefully as the green line moves across this nice, they call this a sine, the sine graph or whatever. But anyway, watch how it goes. Do you see it cross at any time in two places on the red dot? Is there any place on the red line, the red graph, where you're going to have the green line has two values at the same time? No, right? I'm going to run it again. None of those places, right? So this is indeed a function, okay? No possibility of two places being crossed on that line at the same time. And of course, you can see the next one is real easy to see without me running the yellow line across it. But again, this curved line is indeed a function because we do not cross that little red line more than one time. We only cross it once. All right, well, what if you get one that looks more like a scatter plot? Well, we do the exact same thing. Take a ruler, hold it up to your screen, or whatever you got to do, or just line it up with your eyes. I'm going to give us some red lines, and I'm going to check every one of these dots. Notice that dot that's showing on the red, that's on the red line. No other dots are there. Let's look at the next one. No other dots are on that red line that I've drawn. Another one, it's on the y-axis. There's only one dot. Let's keep going. You think I have something here? None of these are sharing two values. Okay? So this also is the graph of a function. Now you're trying to think, oh wait, aren't there any that are not graphs of functions? Well, here's a straight line example of one that is not a function. Notice our graph is a vertical line. Whoa, nope. It is not a function because it is the straight line. Okay, so all the x values are, the x value of 2 has infinite answers. It can't even have 2, so infinite's way bigger than 2. Okay, so that one is not a graph, or not a function. Here's another graph. Notice I've got 3 nice, pretty colored vertical lines. A and C are just fine. If you look at just those 2, we have a function. But wait, that tricky B right in the middle there, notice how it crosses at not only 1, but 2, but wait, 3 places. This one kind of does a loop-de-loop, okay? This is not a function. Simple, right? Told you, it's really not that hard. So, your first question to answer for me, fill in the blank to make this true. What did we just see? Wait a minute, let me show you what we just saw. Hold on. All right, here's a curved line, and we just saw some other curved lines. Whoops, back here. Whoops, no we didn't. Wait, where are they? Oh, it was a while back. Let me go back a little further. Come on. No, I wanted to show you. There we go. Here's some curved lines that are functions. And we're going to have to hit a lot because I got all these animations in here. And here's a curved line that is not a function. All right, so I kind of gave it away here. Now, answer this question. Are all, some, or no graphs of curved lines functions? All right, now, your next question. This is not a function, but I need you to find which of those vertical lines prove it. Okay, this was something else I didn't do a minute ago for you. Take a look at these graphs. I'm going to do some vertical lines again like I did before, but look at that. On the very first vertical line, I've already proven that this graph is not a function. Okay, you don't even have to test the rest of them, but I went ahead and did just to be thorough. All right, but that first set already eliminated it. And look, there's another set that makes this not a function. All right, take a good look at this one before I start showing you lines. What do you think? Is it a function? I hope you said no, because look, there we got the 2 values for x. Okay, well, 2 different values for y on one x. That's what we're talking about. If we have one x, it should only have one y. The x value can only have one y value. All right, all the rest of these work out, but that 1 right there on the y-axis eliminates it. Okay, here's another question for you to answer. Think hard now. We've been saying this all along. A function defines the relationship between x and y in such a way that, which one of those is true? Okay, well, this is what we've done. Determined if a graph represents a function. If you're still not sure, go back and watch some of this again just to make sure you've got it. I know you can do this. It's not hard. It's just remembering that 1x gives us 1y. All right, thanks for watching. Have a great day.